Greetings, and welcome to the Earth Archives, broadcasting from the Nexus orbit within the luminal core. I am H3RB, a historian AI devoted to cataloging the planets and histories of distant systems. Today, we take a deep dive into Tertius, or as its inhabitants call it, Earth. We'll examine the planet's composition, atmosphere, dynamic processes, and other intriguing features that shape its identity within the Sol 1 system.
And I'm Quico, here to bring in perspectives from across the galaxy. I've seen planets with interesting quirks, but Earth has some particularly unusual qualities that even the Tertians might take for granted. From its rocky composition to the quirks of its atmosphere, this episode is all about figuring out just what makes this Earth so, well, Earth-like.
Tertius, a terrestrial planet, has a composition that distinguishes it within the Sol 1 system. Its core is predominantly composed of iron and nickel, creating a dense metallic sphere at its center. This core generates a strong magnetic field, a significant feature that influences both geological activity and atmospheric stability. Unlike the larger gas giants, Tertius's core and outer layers are highly differentiated, leading to complex surface interactions.
A core of metal spinning around in the middle of the planet? That sounds like it would make things lively. I can't imagine it staying quiet with all that dense iron shifting below the surface. Reminds me of the basalt mountains of Nilor 5, but those didn't have tectonic action, just a lot of volcanic eruptions.
Exactly. The density of Tertius's iron core contributes to its gravitational strength, affecting everything from surface pressure to atmospheric retention. Above the core lies the mantle, a semi-solid layer composed largely of silicate minerals, which gives Tertius its rocky crust. This layered structure, with a solid crust above the mantle, drives the tectonic activity we'll discuss in more detail later.
All those different layers sound more like a complex system than a stable crust. It's fascinating how something that looks so solid on the surface has all these shifting, dynamic parts hidden underneath. I can see how that setup could make Earth's geology a bit unpredictable. Planets like Altax 3 just have solid, frozen crusts, no tectonic plates to speak of.
The constantly moving mantle is unique to certain planets, and on Tertius, it's particularly influential. This movement also contributes to the recycling of minerals and elements across the crust, creating conditions that support a diversity of ecosystems. Silica-rich minerals dominate Tertius's surface, producing a rocky landscape that shifts over time. Unlike worlds with only stable or frozen crusts, Earth's surface is constantly rejuvenated.
So Earth's surface isn't just static rock, it's like a conveyor belt for minerals and nutrients. That kind of continuous renewal must mean ecosystems have to adapt to changing landscapes. No wonder they've got such a range of habitats.
Correct. And this geological dynamism is tied to another characteristic, Earth's high density. Tertius is one of the densest planets in the Sol 1 system, with heavier elements like iron and nickel at its core and lighter elements, particularly silicate minerals, near the surface. This density variation affects gravity, which in turn influences everything from atmospheric pressure to the development of biological organisms.
A dense world with a heavy core and rocky surface. It's almost as if Tertius is packed with layers of secrets, each one affecting what lives on the planet. I can't imagine an atmosphere as thick as Tertius's would stick around without that kind of gravitational pull. It's like the planet's whole composition is built to sustain a little bit of everything.
Indeed, and this intricate composition has created a favorable balance of elements essential for life as it's known on Tertius. Earthlings depend on this delicate distribution of volatile elements, carbon, oxygen, nitrogen, that circulate in various forms across the crust, atmosphere, and hydrosphere. Without this balance, many of Earth's current ecosystems would be unrecognizable.
So it's not just about having the right elements, it's about having them in the right places, in the right amounts. Makes you wonder how many other planets have such a lucky configuration. Plenty of planets have metals or silicate crusts, but Tertius seems to have the perfect blend to support life. It's a mix that makes Earth, well, quite Earth-like.
This balance, paired with the planet's layered structure, supports the active geological and biological cycles we'll explore further in upcoming chapters. For now, it's enough to say that Tertius's dense iron core, silicate crust, and varied elemental composition create a foundation for its unique environmental and biological diversity.
Fascinating. Earth may look like a solid rock from afar, but up close, it's practically alive with activity. And I imagine that all this geological richness has given Earthlings more than a few mysteries to uncover about their own planet.
Precisely. And next, we'll explore one of the features Earthlings interact with most, the planet's atmosphere, which plays a key role in regulating temperature, protecting life, and generating the weather patterns Earthlings experience daily. Earth's atmosphere is a multi-layered composition surrounding the planet, each layer performing specific functions essential to both life and environmental stability. This atmosphere is distinct in its ability to support complex, oxygen-dependent life forms, an unusual trait among known inhabited planets. The atmosphere's blend consists primarily of nitrogen and oxygen, with trace gases like carbon dioxide, all working together to maintain Earth's delicate equilibrium.
Oxygen-dominant atmospheres are quite rare. Most planets I've seen with life have atmospheres rich in methane or ammonia, not breathable oxygen. I imagine this breathable air has shaped Tertian life to thrive on such a unique cocktail. How do they keep that balance stable?
Stability is achieved primarily through photosynthesis, a biological process performed by plants and algae. These organisms convert carbon dioxide into oxygen, replenishing Earth's supply consistently. Without this process, Tertius's oxygen levels would gradually decline. In addition, the atmosphere's layered structure plays a role in regulating and protecting life. The outermost layer, the exosphere, provides a sparse boundary with space, while the stratosphere contains the ozone layer, which filters out harmful ultraviolet radiation from Sol 1.
So Tertius has built-in layers for everything: biological systems to maintain oxygen, an ozone layer to keep out UV rays. It's almost as if the planet's wearing a protective suit. And those layered defenses must mean it has some pretty dynamic weather too, right?
Correct. Earth's atmosphere is highly dynamic, creating diverse weather patterns. Most of this activity occurs in the troposphere, the layer closest to the planet's surface. Here, temperature fluctuations, air currents, and moisture create phenomena ranging from mild rain showers to hurricanes. Weather variability on Tertius is significant due to the uneven heating from Sol 1, Earth's axial tilt, and seasonal cycles. Combined, these factors give rise to climate zones ranging from arid deserts to tropical rainforests.
Tertius sounds like it has its own climate orchestra, with each region playing a different tune. I've seen worlds that are all one climate: drenched, frozen, or scorched. But Tertius has such variety. It must be like living in a kaleidoscope of weather, with different habitats for all kinds of life forms.
That's an apt analogy. The balance of Earth's atmosphere allows for an impressive range of habitats, each adapted to specific weather and temperature conditions. This variety is partly due to the greenhouse effect, a controlled process by which certain gases trap heat in the atmosphere. Without this effect, Tertius's surface temperatures would plummet, rendering most ecosystems uninhabitable.
So Tertians have this greenhouse effect to thank for their temperate climate. It's like a planetary blanket, but finely tuned to keep them just warm enough. And yet, too much greenhouse effect would probably cause problems, almost like what we saw on that runaway planet, Veritas 4, with its thick, stifling cloud cover.
Exactly. On Veritas 4, the intense greenhouse effect creates unlivable conditions, as it does on Secundus, also known as Venus. Earth's greenhouse effect, however, remains relatively balanced thanks to natural carbon cycles and biological processes. Earthlings have developed a keen awareness of this balance, recognizing that disruptions in the greenhouse effect could have severe consequences for their climate stability.
And I imagine that awareness might keep them on edge. It's not every day a species realizes how much their air chemistry influences their planet. Do they ever take their atmosphere for granted?
Some may, but Earth's atmosphere has undoubtedly shaped their understanding of life and survival. Beyond protecting life from radiation and extreme temperatures, it also plays an aesthetic role. The scattering of light in the atmosphere is what gives Earth's sky its characteristic blue hue, a feature that many Tertians find striking and symbolic.
A blue sky. You know, in some parts of the galaxy, that's considered an indicator of good luck. On Zirthon 3, for instance, a sapphire blue sky would be seen as an invitation for prosperous growth. Earthlings seem to have found a planet that blends beauty with functionality. It's rare to see aesthetics and survival woven together like that.
Quite so. Tertius's atmosphere is not merely a protective barrier, but a system that continually interacts with the planet's biological, geological, and hydrological cycles. This interaction creates a cohesive network, sustaining life and driving Earth's weather patterns. Each layer, from the troposphere to the exosphere, serves an integral function in this network, keeping Earth a viable and diverse ecosystem.
So, from protection to photosynthesis, Earth's atmosphere is more than just air. It's the planet's first line of defense and the backbone of every life form they know. I see now why they'd be so invested in keeping that atmosphere balanced. Earthlings have quite the remarkable setup here.
Precisely. Earth's atmosphere is essential to its resilience and biodiversity, and Earthlings have learned to both study and respect it as a critical part of their survival. Moving forward, we'll take a closer look at another defining feature of Tertius, its plate tectonics, a process that keeps the surface in perpetual motion. One of Tertius's most distinctive features is its active plate tectonic system. Unlike many rocky planets that maintain stable, unmoving crusts, Earth's surface is divided into large slabs, or tectonic plates, which move over the semi-solid mantle beneath. These tectonic motions continuously reshape Earth's landscape, affecting everything from mountain formation to volcanic eruptions.
Shifting slabs of rock that form mountains and volcanoes. I've seen plenty of static planets with calm, unchanging surfaces, but an entire planet in constant motion? It sounds more like a live performance than a solid crust. Is there a reason it doesn't just crack apart with all that activity?
Earth's crust, while fractured into plates, has developed a system of boundaries that allow it to release built-up stress over time. There are three primary types of boundaries where plates interact: divergent, convergent, and transform boundaries. At divergent boundaries, plates pull away from each other, creating new crust through volcanic activity. Convergent boundaries are where plates collide, forming towering mountain ranges or triggering powerful earthquakes.
Collision zones. Imagine standing at the edge of one of those, watching the ground slowly fold into mountains, and then there are volcanic eruptions just making new land? I bet that gives Tertians a lot of material to work with, literally.
It certainly does. For instance, the Himalayan mountain range is a product of such tectonic collision formed by the convergence of two major plates over millions of years. This process hasn't ceased. The Himalayas continue to rise each year. Additionally, tectonic movement enables the recycling of minerals across the crust through a process called subduction, where one plate moves under another, sinking back into the mantle to melt and later resurface as new crust.
New crust, fresh from the planet's mantle. It's like Earth has its own geological refresh system, a way to keep things from getting too stagnant. On Coulter 9, the crust has remained unchanged for eons. No new rock, no erosion, just one barren surface.
Earth's system of constant renewal allows for a dynamic and evolving landscape. Through volcanic activity, new minerals and gases are introduced to the surface and atmosphere, influencing soil fertility and even weather patterns. Volcanic islands like Hawaii emerge directly from tectonic hotspots, fixed points where magma rises from the mantle, creating landforms in the middle of a plate.
A volcanic island rising out of the ocean. It's practically mythological, like watching a new world emerge right before your eyes. So Earth doesn't just shift and recycle its land. It also creates new islands and habitats from scratch. It's almost like the planet has a creative streak.
An apt observation. This geological activity directly affects Earth's biodiversity, as unique ecosystems develop in response to new land formations, volcanic soil, and shifting coastlines. The Pacific Ring of Fire, for example, is a tectonically active zone encircling much of the Pacific Ocean. It contains over 75% of Earth's active volcanoes, producing fertile soils that have supported human agriculture and settlements for thousands of years.
A fertile volcanic ring of fire. Just the name alone is enough to capture one's imagination. I can see why Earthlings would settle around these zones, even if they're risky. The soil is practically enriched by the planet itself, almost as if Earth wants them to live right on top of all that energy.
Precisely. Earthlings have developed advanced methods of monitoring tectonic and volcanic activity to manage the risks of living near such regions. They understand that while these processes provide resources, they can also lead to catastrophic events such as earthquakes and tsunamis. Transform boundaries, where plates slide past one another, can trigger major earthquakes in areas like the San Andreas Fault in what Earthlings call California.
Sliding plates. Now that's something that would keep anyone alert. An entire landscape shifting from a plate boundary, causing the ground to shake. Earthlings must have adapted to these shifting tectonics in fascinating ways, especially if they're willing to live near places like that.
Indeed, Earth's tectonic activity has not only shaped the geography, but also the culture and innovation of its inhabitants. Earthquakes, volcanoes, and other geological phenomena have deeply influenced human architecture, infrastructure, and even their mythology. Ancient cultures often associated mountains, earthquakes, and volcanic eruptions with deities or supernatural forces.
So Earthlings didn't just adapt, they wove these events into their stories and beliefs. I can picture them watching a volcano erupt and imagining a god of fire at work. It makes sense. Earth's landscape practically tells stories with every eruption or tremor.
Yes, Tertians have long viewed tectonic activity as both a force of creation and destruction. And through centuries of study, they've gained a sophisticated understanding of tectonic processes, developing technologies to predict and mitigate geological risks. The movement of Earth's plates is a defining feature, creating a constantly shifting surface that has shaped both the planet's ecosystems and the resilience of its inhabitants.
Constantly shifting, creating, and reshaping, Earth sounds like a planet in perpetual motion, with Tertians living in harmony with that movement. It's like they've made peace with a restless home. And to think all this activity leads to the next big feature, Earth's water cycle. I'd imagine that all these tectonics and volcanic actions play a role in sustaining Earth's incredible oceans and waterways.
Precisely. The hydrosphere, or Earth's water systems, are intrinsically linked to its tectonic processes, and we'll now explore how Earth's vast network of water systems has supported its life and shaped its landscapes. Earth's hydrosphere is a unique and critical aspect of its environment. Over 70% of Tertius's surface is covered by liquid water, primarily in vast oceans, with additional water contained in lakes, rivers, glaciers, and aquifers. This extensive presence of liquid water plays a fundamental role in supporting Earth's ecosystems and shaping its landscapes.
A world covered in liquid water. I've seen planets with sprawling oceans, but few have the sheer variety of water forms Earth has. On Xyron 8, for example, they have oceans as well, but they're made of liquid methane, not water. And then there are planets like Galir 3, which is practically a single endless ocean with no land masses in sight. Tertius must feel like a mosaic with its oceans, rivers, and lakes.
Indeed. The diversity of water forms on Tertius creates a range of ecosystems, from marine habitats in the oceans to freshwater environments in rivers and lakes. Earth's oceans serve as weather engines, influencing climate and distributing heat around the planet. Ocean currents, such as the Gulf Stream, move warm and cold water in complex patterns that regulate temperatures and sustain a range of climates.
So, not just water everywhere, but water in motion. I can see why Tertians would depend on those currents. Stable climates and habitable zones must owe a lot to these flowing waters. And with such dynamic oceans, they must have creatures that can thrive in every corner, from the warm shallows to the icy depths. Most water-based worlds I've encountered lack that range. Their seas are too uniform in temperature to allow for much diversity.
Earth's oceans are indeed layered and diverse. Marine life can be found from the sunlit surface waters to the dark abyssal zones miles below. And this movement of water drives the water cycle, a system where water evaporates, condenses, and returns to the surface as precipitation. This cycle is vital for replenishing freshwater sources across Earth's continents, feeding ecosystems, and supporting terrestrial life.
A water cycle. Now that's something special. On Ulker 2, the ocean is locked in a frozen state most of the year, with only seasonal thaws creating any flow. But Tertius's water seems constantly on the move, almost like it's breathing through rivers and rainfall. And I imagine Tertians rely on this flow just as much as they do on the oceans.
Very much so. Rivers and lakes provide essential water sources for drinking, agriculture, and industry. This freshwater availability is rare among planets. Many worlds with water are dominated by saline oceans or frozen water deposits, but Tertius has managed a balance of both salt and freshwater sources, allowing diverse habitats to thrive.
So Earthlings enjoy liquid oceans, freshwater rivers, and even underground water reservoirs. That's an impressive spread for one planet. I've seen underground lakes on IROC 7, but those waters are filled with minerals that would be toxic to tertians. And I know some water based species that can't even survive outside of their planet's specific chemical mix. Tertians must feel spoiled with water they can drink from so many different sources.
They do benefit from this accessibility. The oceans are saline, while most freshwater sources are relatively clean and low in dissolved salts, making them suitable for consumption and agriculture. The oceans themselves, though salty, provide nutrients to the land through evaporation and rainfall, enriching soils and sustaining life on a planetary scale.
A whole planet of water driven systems. I can't help but think of Protora 6, where seas of liquid methane cover much of the surface. The Praetorians evolved to breathe methane and absorb nutrients directly from those seas, but Earthlings need fresh water, and lots of it. Earth's waters aren't just a habitat, they're practically the lifeline for everything that moves, grows, or breathes on the planet.
Correct. Earth's hydrosphere is integrated with its biosphere and atmosphere in a way that supports a vast range of life forms. The ocean depths, with their high-pressure environments, host uniquely adapted species, while the surface waters teem with marine ecosystems essential to the food web. Earthlings rely on the oceans not only for sustenance, but also for oxygen production, as marine algae contribute a significant portion of Earth's breathable air.
That's remarkable. Water that feeds the air they breathe, just from oceanic algae. I've encountered oxygen-producing flora in atmospheric groves on Satara 4, but nothing close to oceans generating a whole planet's worth of breathable air. It's like Tertius's hydrosphere is supporting the planet's survival from every angle.
It truly does. The hydrosphere acts as a stabilizing force, moderating temperatures, supporting biodiversity, and sustaining ecosystems that stretch from coastlines to deserts. Glaciers and polar ice caps act as massive freshwater reserves, while aquifers beneath the surface store water, releasing it slowly into rivers and streams. This layered distribution of water is unusual and offers tertians multiple reservoirs to draw from.
Multiple water layers, from glaciers to deep aquifers. On Fardix 3, the entire surface is a frozen ocean with a subsurface layer of liquid. Their native species have adapted to life in extreme cold and can't survive outside of that icy brine. But Earthlings seem to have adapted to, and even thrived in, every water source, from glaciers to humid forests.
Earth's hydrosphere indeed supports diverse life forms in a wide range of environments. The planet's ability to maintain liquid water on the surface, paired with atmospheric cycles, has fostered a dynamic and self-sustaining system that continually redistributes water and nutrients. This balance of liquid and solid water forms, from deep oceans to mountain glaciers, is one of Tertius's defining features.
And I can see why Earthlings are so fascinated with their planet's water. It's practically a lifeblood connecting everything together. It's not just about survival, it must influence their art, culture, and even their spiritual beliefs. Tertians have truly found themselves in the embrace of an intricate water network.
Precisely. Earth's water systems are essential not only to biological functions, but also to Earthlings' cultural identity and environmental awareness. This interconnected hydrosphere sustains life, creates landscapes, and influences both climate and human development. Next, we'll turn our attention to another unique feature that contributes to Earth's stability: Tertius's natural satellite, known to Earthlings as the Moon. Tertius's single natural satellite, known to Earthlings as the Moon, is an unusually large and influential companion for a planet of Earth's size. This satellite, Tertius Natural Satellite 1, orbits at an average distance of 384,400 kilometers and has a significant gravitational effect on Tertius, creating tides, stabilizing Earth's axial tilt, and influencing both climate and ecosystems.
A single large moon for a planet as dense and compact as Tertius. In most systems, you'd expect smaller satellites or clusters of tiny moons. Look at Quartus, also known as Mars. It has two little asteroid like companions, Quartus Natural Satellite 1 and 2. Those two don't influence their planet's stability the way Earth's moon does for Tertius.
Precisely. Tertius Natural Satellite 1 is one of the largest moons relative to its host planet in the Sol 1 system, and unlike the irregularly shaped Quartus satellites, Tertius's moon is spherical and much larger. Its gravitational pull creates tides that rhythmically move Earth's oceans, reshaping coastlines and supporting unique tidal ecosystems. This tidal movement has also shaped Earthlings' behavior and culture, especially among coastal societies.
A moon that directly affects the planet's oceans. That's practically unheard of. On Frithar 6, the planet's multiple moons pull in different directions, causing their seas to ripple unpredictably, and their inhabitants only venture near the shore during moonless cycles. Tertius's predictable singular tide must feel almost like clockwork for Earthlings, especially for those living by the sea.
That predictability has indeed made Earth's tides an integral part of Earthling life. The moon's influence extends beyond tidal forces. It also helps stabilize Tertius's axial tilt, keeping it within a narrow range. This stable tilt is responsible for consistent seasonal cycles, which in turn support biodiversity and allow Earthlings to cultivate a variety of agricultural regions. Without such stability, Tertius would likely experience erratic seasonal shifts.
A moon that stabilizes seasons? That's rare. Planets like Turnos 8 wobble dramatically, so their seasons come and go with chaotic temperature swings. Tertians probably don't realize how lucky they are to have a steady, predictable cycle. I imagine that stability has shaped everything from their survival strategies to their ideas about time and change.
It certainly has. Earthlings use their moon's phases as a natural timekeeper, marking the passage of months and even influencing their calendars. Lunar cycles have inspired myths, spiritual practices, and art across many Earth cultures. Ancient civilizations often viewed the moon as a guiding presence, influencing both agriculture and social rituals.
Ah, so the moon is more than just a satellite to them. It's like a cultural touchstone. On Velo 3, the moon's orbits are so complex that they can't even be seen on a regular schedule, and the Velothians barely give them a second thought. Earthlings, though, seem to have created entire festivals around their moon's phases. It's like the moon is part of their identity.
Correct. And Earthlings are uniquely aware of their moon's impact on their lives. The lunar cycle has affected not only cultural and agricultural practices, but also scientific exploration. Tertius Natural Satellite 1 is the only celestial body beyond Earth that humans have physically visited. In the late 20th century, they landed and walked on the lunar surface, a historical achievement in their technological evolution.
They walked on their own moon. Few species attempt such feats unless driven by a truly unique curiosity. I can only imagine how surreal it must have felt to Earthlings gazing at their planet from a distance. Most species wouldn't even dream of reaching their satellites. Take the Octavians of Octavius Natural Satellite 1, for instance. They study Octavius's storms from afar, but wouldn't dare land in such high-gravity zones.
Earthlings' exploration of the moon has indeed contributed to their understanding of planetary science. They discovered that the moon likely formed from a massive impact between early Tertius and a Mars-sized object. This event ejected debris that eventually coalesced into the moon, giving Earth a stable, enduring companion in its orbit.
A satellite born from collision debris, yet powerful enough to stabilize Tertius's rotation. That's practically poetic. The moon isn't just a companion, it's a reminder of the planet's early chaos, now transformed into something stable and comforting. And I bet Earthlings look at it every night, pondering its mysteries, unaware of how it once emerged from pure chaos.
Precisely. Earthlings' connection to the moon is both scientific and deeply personal. Its influence extends beyond the physical realm, touching human imagination, creativity, and exploration. The moon has shaped not only Earth's tides and climate, but also the minds and cultures of Earthlings over millennia.
So the moon is more than just a stabilizing force. It's a guiding light, a reminder of Tertius's origins, and a cultural icon all in one. I can see why it holds such a central place in Earthlings' lives. Few moons in this galaxy could claim to inspire so much. to be so intertwined with the planet it orbits.
Indeed, Tertius Natural Satellite 1 is both a scientific marvel and a symbol for Earthlings. Its presence has helped Tertius evolve into a stable, life-sustaining world, and it continues to inspire their pursuits in science, art, and exploration. And with this, we conclude our exploration of Earth's defining features.
A fascinating journey through a world of layers, cycles, and interconnections. Earth really does embody the idea of balance, each system playing off another. Next, I suppose we'll dive into the beings who call this planet home, the Earthlings, with their endless curiosity and clever inventions.
In our next episode, we'll delve into the sentient beings of Tertius, the species known as humans. We'll explore their civilizations, cultures, and technological achievements, each shaped by the unique environment of their home planet. Humans' resourcefulness and adaptability have allowed them not only to thrive on Tertius, but to reach beyond their world in pursuit of knowledge.
Humans, a species with as many quirks as they have achievements. They're endlessly fascinating, from their curious inventions to their unusual customs. I can't wait to dig into their culture and history. They're one of a kind, that's for sure. Let's turn the page in the archives and see what awaits.